Given 2y minus 2x is equal to 6, what's the y-intercept written as a point? When it says y-intercept, what are we looking for? Yeah, it's when x is equal to 0, right? So it's crossing the y-axis where, guys, think xy. If it's crossing the y-axis, that will be when x is equal to 0. So we can say, okay, we know the y-intercept is when x is equal to 0. That is so true. No matter what the function, when x is equal to 0 is where it's going to cross the y-axis. So it says written as a point, so we know it's going to be 0, comma, question mark, right, everybody? X, comma, y. These are x, y points. So we know we're plugging in 0 for x into our function. So we have 2y minus 2 times 0 is equal to 6. So y, we have 2y minus 0 is equal to 6, right? So we have 2y is equal to 6. Solve for y, what would we do? Divide both sides by 2, so we get y is equal to 3. So as an xy point, it's no longer question mark, it's 0, comma, 3. So we would put it in, this is what it would look like in on the computer. So you would put in a 0 here and a 3 here. Is everybody comfortable with that? Questions on that? So y-intercept is always when x is equal to 0. So don't forget that. That's usually a pretty easy problem. Do we have any questions? Next problem. Okay. So write that down. Number 2. Problem number 2. It says the square root of negative 8 is equal to what? Remember, this is not new to us. We've seen this problem before. So is the square root of negative 8 just a negative? No. What is it? I. Good. If we have the square root of negative 1, it's I. So remember, the square root of negative 8 is technically the square root of negative 1 times by 8. So I like that you say, okay, that's going to pull out and be an I. So we'll remember that, and then we'll break down 8 by hand. So 4 times 2, and then 4 breaks down into 2 times 2. Because it's a square root, it goes without being said, there's a 2 in here, so we're pulling out groups of 2. If there's 2, they can leave the house, not 2s. If there's 2 3s, they can leave the house. If there's 2 apples, they can leave the house. So we have 2 2s. We pull out a 2 for those 2 2s. Because remember, we're technically doing the square root of 4, which is 2. So we pull out a 2. We also pulled out a I, because of the negative under the square root, and left underneath is a 2. Now I have people still not understanding that to be able to leave the house, remember how we talked about when you're little, your parents won't let you leave the house without a buddy, so that's why we leave it in buddies, okay? So a lot of people are still putting it in the house, but remember, everybody always wants to leave the house. You don't want to be cooped up in the house. So if you pull something out, it leaves the house. People switch these and put this underneath, and I don't know why. Okay. Questions on that one? Okay. So you're this person. You're the loner that stays in the house. All right. So let's do this one. The cube root of 40 is equal to what? Okay. This one's a cube root. Nevertheless, it's the same idea as a square root. We'll break it down to its prime factors. Remember, prime means only divisible by 1 in itself. So nothing multiplies to be it except for 1 times itself. So 40 breaks down into 4 times 10. 4 is not prime, 10 is not prime. We can keep breaking it down. 4 breaks down into 2 times 2. Once again, 2 is prime because it only multiplies by 1 in itself, right? 2 times 1, are those the only factors of 2? Yes. Okay, now 10 breaks down into 2 times 5. Now don't double dip. I still have people double dipping. If you need to, say the 4 is not there, it's 2 times 2. The 10's not there, it's 2 times 5. Because it's a cube root, we're pulling out groups of 3. They have to leave in buddy system of 3. So there's 3 2s, so can't they leave the house? So we pull out a 2, and then left underneath the house was a 5. Now make sure you don't write square root of 5, that would be incorrect. It's the cube root. It was a cube root of 5. Questions on that one? So what if I pulled out 2 things? What would I do with those? Would I add them? Multiply them? What?
You would add them. No, multiply.
You multiply, right? Anything left under the house, you multiply. Anything you pull out, you multiply. There was no addition in this problem whatsoever, so we don't magically put in addition signs. Okay, a couple more, guys. Only a couple more, then I'll let you work on the stage review packet. So you need to be writing down every single one of these problems. You know that, right? For your notes, everybody understood that? Okay, so this next one's kind of interesting. It's going to take a little bit of thought, which I think we can do. Now, your problem might be different than mine. Your answer might be different than my answer. But let's just think through this one together, and then hopefully it will help you see how you could think through this, okay? So it says, number 4, write a statement to make this true. So we have box square root of box plus box square root of box will equal 8 square roots of 2. So we have this statement and this statement. So then we have also this box square roots of 18 minus box square roots of box is equal to the square root of 2. And then we're given these numbers. So we're going to be clicking and dragging and putting these in to make a true statement. Now understand, once you've clicked and drawn and put something somewhere, you can't use it again. So we'll exit out. So this is like getting you prepared for a stage. So it would say click and drag to make a true statement. Do you always understand that this is like a word box? Do you get what I'm saying? But it's a number box. So you can use any of these things to make a true statement. Okay, so it says write a statement to make this true. So I guess let's see if we can think through this one. So do you guys understand that this just means you're putting in a number here? Okay. So first thing on the top one, does everybody understand that the answer is 8 square roots of 2? So don't we need to be doing the square roots of 2 in here? Okay. So, and I believe if I am thinking right, you can only use the number once, but maybe I'm mistaken. I'll have to think about that for a second. So this one's actually going to be a little bit harder if you can only use them once. In fact, much harder. So let's think about this. I'm wondering if we can use them more than once. So I'm trying to decide if I want to let us use it twice. Yeah, for now. Let's keep it easy today. And then we'll come back to this problem another day and only use the numbers once. Does that sound like a good deal? Okay, so you can use the numbers twice, let's say. So won't these need to be square roots of 2?
Yes.
Yeah, so let's put a 2 here and here. Okay, so what plus what could equal 8? What plus what could equal 8? There's a million answers. 6 and 2. I like 6 and 2. So we take another 6, we take a 6, put it here. We take a 2, we put another 2 here. So 6 square roots of 2 plus 2 square roots of 2 is that 8 square roots of 2? Yes, right? The square root of 2 part doesn't change, right? We can combine them because they're alike. Okay, awesome. So let's do this next one. So our final answer needs to be the square root of 2. Now, here's the catch. This one's a lot harder. Because isn't the square root of 18 actually, couldn't we simplify it? Can't we break down 18? We need to, right? So let's do that. So 18 breaks down into 9 times 2, and 9 breaks down into 3 times 3. We're pulling out groups of 2, so we'll pull out a 3. So I'm going to rewrite this. We have box and then times 3, because isn't this multiplied on the outside? So anything we pull out won't be multiplied to it. So we have box times 3, and then we have the square root of 2. We just simplified the square root of 18 to be 3 square roots of 2. Is everybody comfortable with that?
Yeah.
Okay, so now let's think about it. So we have box times 3 square roots of 2 minus box square roots of box, which is equal to the square root of 2. So don't we need this one also to be a square root of 2 in here?
Yeah.
To combine them, which will help us. So let's grab a 2, put it in here. So I'm going to change colors. So we'll put a 2 right here. So now we have blank square roots of 2 minus blank square roots of 2 is equal to 1 square roots of 2. So let's go with this one first. Let's put in some number, and then let's put in another number. So I'm going to make it easy on myself. I'm going to use 1. Is everybody comfortable with that? Okay, so I'm going to put a 1 in right here. So wouldn't that be 1 times 3, which would be 3 square roots of 2? So we have 3 square roots of 2 minus box square roots of 2 will be equal to the square root of 2. So what does this need to be to make it a 1 square roots of 2? What's 3 minus 3? 0. That'd be 0 square roots of 2, which would be 0, right? Good try? Good try? So it'd be 2. Awesome. Guys, good. You're thinking through it. That's great. So 2. So if we put a 2 in here, let's see if that makes a true statement. 3 square roots of 2 minus 2 square roots of 2 would be 1 square root of 2. Isn't 1 square root of 2 the square root of 2? So we did it. Yay. I feel like you must be able to use the numbers twice, but we could challenge ourselves another day and only use them once, and we'd really have to think hard. Questions on that? Because we use that 2 a lot, right? You know what I mean? But all right, good job, guys. It's all about just thinking through it. Okay, only a couple more. So it says on number 5. So write this down. Given v is equal to pi r squared h, it just says solve for h. Solve for h. This should be really easy for you. if you don't get thinking too hard about it. Simply solve for h. These are called literal equations, meaning you can solve for any variable just using algebra, which we've actually gotten really good at algebra in this year. So let's go ahead and solve for h. Doesn't solve for h just mean get h alone.
Yeah.
So let's look at this. We have v is equal to pi r squared h. Isn't all this multiplied?
Yes.
So how would we get h alone? Good. Divide by pi r squared. It's that easy. Way to go. So we divide both sides by pi r squared. So those divide out and become 1. H is alone. So our answer would be h is equal to v over pi r squared. So that was a really easy problem. Hopefully you wouldn't think too hard about it and you just get it right off the bat. So if I would have said solve for r, let's just throw that in there. Instead of solve for h, what if I changed it and said solve for r? So we have v is equal to, you don't need to write this down, but let's think about it, you advanced thinkers here. We were solving for r, couldn't we divide, isn't this all multiplication? So couldn't we divide by pi and h? Divided by pi and h, you have to do it to both sides.
Square root.
Yep, good, yes. So those divide out and become 1. So we have v over pi h is equal to r squared. Good. And then, good, Elise. So you said now we just square root both sides, right? Nice. Awesome job. Literal equations. Okay. Okay, so now you're working on those are the Sage Review problems for today. Just getting your brains going. You need to be working on pages 8 through 12. I changed this, I forgot. 8 through 12. Ready, set, go. The rest of the time is yours to check with me. I'll initial your page once you've got them right. Do not waste any time, please.